Hey guys, we are going to go over the Unit 2.4 Geometry Proofs segments notes. But first, so this is the page we're going to be looking at the back of your packet. There is this Proofs Reason Codes. So I want you to turn to that real quick. Alright, so we're going to talk about these. We already talked about the first 5 of them. You've seen them last class. So we're not going to rewrite those in there. You can transfer them if you would like from your 1.3 notes, or 2.3 notes. We're going to start here under this transitive property of equality. Okay, I'm going to be writing, it's kind of a lot right here in this box, so make sure you write small. But I'm going to write it, and I want you to copy it, and then I'm going to explain it. So don't overthink it while you're writing. So if actually, I'm just going to show you this. So pause the video and write it if you need to. But here we go. We're going to talk about, so if we have AB and it's congruent to BC, okay, that needs a little lid there, and you know that BC is also congruent to CD, so like this is going to already be given in your statement side. Then what's going to happen is AB and CD are going to be congruent. And if you're like, wait, how do I know that? Well, two things that are equal or congruent to the same thing are going to be congruent to each other. It's just like saying, like, if A equals 7 and B equals 7, then A and B equal each other. Okay? But this is kind of how it will look for geometric proofs, and that's why we're writing it this way. So for a transitive property of equality, I always like to circle the things that it's missing there, or the things that are the same. Okay? Alright, so pause the video and copy this one down. Alright, hopefully you paused it and copied it. Okay, this one's going to be a little different. So these are the most mixed up ones. People get confused on which one's transitive, which one's substitution, because they can look very similar. So if you have something like this in one of your steps, where AB plus BC is equal to AC, and it also tells you that BC is going to equal to XY. Okay, so BC is one of the ones in this equation right here. And then the next step, let's say it's substitute. So instead of writing BC, it writes XY. So it's substituted XY instead of BC, and it wrote it in there. So that's why it's called substitution. The difference between these, because you may be like, wait, we substituted up here. The difference between this is it's the entire half of the equation. It's one side of the equation. So we circled one side of each of the equations, and then we smashed the equations together. Alright, and that's the difference here. All we did was substitute a piece of one side of the equation, but here for transitive property we took two halves and set them equal to each other. So that's the difference there. The next one is going to be, and I got a little crazy here, just part plus part equals the whole. So that's what segment addition postulate and angle addition postulate looks like. Part plus part equals a whole. Here's an example of what it could look like. Anytime you see part plus part equals a whole, a random addition sign coming out of nowhere, that is going to be, typically it's going to be segment or angle addition. Okay. Feel free to pause the video anytime if you need to make sure you're copying these down. Okay, reflexive, we're going to write this, but you will not see this until we get to like congruent triangles. So we're going to write this so you know it, like, but I don't want you to think about it too much. This is not going to be something that pops up a lot during this particular unit. Okay, moving on to symmetric. This one you will see. So we're going to write this reflexive down. You won't see it a ton. Reflexive you will see. So notice what happens. AB is congruent to BC. Needs to be then. Then all we do is we flip it. That's it. Nothing changes, it just flips. Okay, so make sure you have that down. Next, so for midpoint and bisect, they're pretty much the same, all right? For definition of midpoint and definition of bisect, they kind of mean the same thing. So they both mean to cut in half. And the example of both of them, it's going to, if something is the midpoint, like on a segment, then midpoints technically bisect the line. So it cuts the line in half. So it would just be saying like this segment is congruent to this segment because it is cut in half by the midpoint. And same thing for definition of bisect. It cuts in half, and then we've got two congruent segments. Example would be AB is congruent to BC. And this doesn't have to make a lot of sense right now. We will go over it and it will make much more sense later. But I just wanted you to have all the reasons in one space. Okay, so if AB is congruent to BC, then AB will be equal to BC. That's the definition of congruent, because congruent means equal. So notice the letters did not change at all, just the squiggly disappeared and the things on top disappeared. Don't overthink it. That's definition of congruent. If you see something going from this to this, how did we get there? Definition of congruent. It can also go backwards. You can go from equal sign to congruent symbol. Okay, moving on up. Definition of complementary angles. Two angles that add to 90. So it's going to be something like this. Measure of angle 1 plus measure of angle 2 is going to equal 90. Definition of right angles. A right angle means that it equals 90. So ABC is equal to 90 degrees. That's what the definition of a right angle is. Again, feel free, anytime you need to, pause the video. Okay, if you see something like this, if you see this perpendicular symbol, so if AB is perpendicular to BC, then ABC is going to be a right angle. How do we know that? Because we know that perpendicular means right angle, or 90 degrees. All right, we know that supplementary angles means two angles that add up to 180. That's what that one will look like. And then vertical angles are just two congruent angles, angle 1 and angle 2. So angle 1 is congruent to angle 2 because they're vertical. So like the picture will show that they're vertical, and then the statement will show that they are congruent. Flip back over to the proofs. We're going to do 3 of these together. It also, it talks more about these. We already wrote those down, so I'm not going to discuss it much. Here we go. We have AC is congruent to BD, and we know that because it's given. So if we look here, AC is congruent to BD. How do we know that? It's given. All right. And then make sure that you are down here not writing the word prove. You will never write the word prove on that side. Okay. So we are going to be using these proofs reasons that we just wrote down in conjunction with here these. So it's going to be one of these reasons on this page that we have to fill in. So it's kind of like we're matching. We've got to understand what's going on. So remember how we talked about with algebraic proofs? You would go from this step to this step, and your answer would be, how did I get here? So how do I know that AC is equal to BD? Well, we talked about this before. When there's no change at all, A, B, and BC, as far as the letters, and it goes from congruent to equal sign, it's going to be definition of congruent. Okay. So you've got to be able to identify that. Okay, no change except squiggly to equal sign. Boom, definition of congruent. All right, and then I also talked a little bit about, hey, what if there is just a random addition symbol out of nowhere? It's not in the given, it's not up here, and then it just appears all of a sudden. And then you look up at your picture and you're like, oh, AB plus BC is equal to AC. That's part plus part equals whole. Okay, if we look back and we're like, oh, which one's part plus part equals whole? it's going to be this segment addition postulate. And if it was angles, it would be angle addition postulate, but we're talking about segments here. So we've got 2 times where these come out of nowhere. So we've got to look back at the picture. BC, part CD plus part equals the whole thing. Okay, that makes sense. Just make sure you check your picture, because it is possible that it's not that. Alright, so you've got to check and make sure part plus part equals whole makes sense. Segment addition postulate. Wonderful. Okay, this next one, it's a bit confusing. Okay, so we know we may have to look, this is what's different about algebraic proofs and then compared to geometry proofs, is you may have to look in 2 previous statements to figure out a statement. Before it had just been like, yes, yes, next, next. Now it's like, oh, we've got to look at everything we've written and try to figure out what could work. So we're trying to figure out, how do we know that AB plus BC is equal to BC plus CD? So how do we know that this and this are congruent to each other? Okay. And really, the 2 things that we're looking at is either transitive or substitution, trying to figure out which one is it going to be. So you've got to remember in your head, transitive is only if an entire half of an equation are the exact same, and then we can take the other half and smash them together right here. So substitution is if we are just taking a piece of something and setting it equal to another equation. Okay. So up here, I can't find any, these 2 sides of the equation are not the exact same. Like if this was AC and that was also AC, that would be transitive, because they'd both be the same and then they equal each other. But instead, this one's a little tricky, because what we're doing is we are substituting. So AC, we know that AC is equal to BD. So we are taking that and we're like, okay, so we're going to substitute that in and then realize that it is the same thing. Okay, so it's just going to be substitution. Okay, basically what you're looking for, and like this is kind of a confusing one, and this is why we put this on the notes. The ones on the assignment are more straightforward, but if you can't circle 2 halves of an equation that are the exact same, so since this and this are not the same, then it's going to be substitution, because you are substituting this part of the equation in to equal AB plus BC. Okay, and we'll go over more transitive on the next problem, and it will make more sense. I get it, this is confusing right now. Alright, and then if you're going from here to here, you've got to notice something that's happening. Something is disappearing from here and here. So if you get rid of that BC, so you subtract BC on both sides, then it will disappear, and all you're left with is AB is equal to CD. So, for example, you have subtraction property of equality, because you're subtracting on both sides of the equation. So this looks a lot more like those algebraic proofs that we did. Alright, then we go back to the no change. We're going from equal to congruent sign. Definition of congruent. You may be confused. You're like, whoa, we've already had definition of congruent. What's going on? Well, yeah, that's allowed. You can have it twice. Definition of congruent. Okay, I don't want this substitution to trip you up too much. That was confusing. Okay, but I want you to think, as we go through transitive examples on the next proof, I want you to think of the difference between these, okay? So we are looking at this, and this is the given. B is the midpoint of AC, and C is the midpoint of BD. Cool. It's written right there. Then you have AB is congruent to BC, and BC is congruent to CD. And you're probably like, well, okay, what does that mean to me? Well, here's what I want you to do. Anytime you're looking at the given, if you see a word that is one of these definitions that we wrote down here, I want you to circle that word automatically. Circle it. Because 99.9% of the time, the next step is going to be the definition of that word. So if we look back at definition of midpoint, we have cuts in half, example. AB is congruent to BC. So the reason that is the definition of midpoint is because a midpoint cuts a segment in half. So if B cuts AC in half, AB is going to be the same as BC. So definition of midpoint. Alright, and then going from here to here. Okay, now, how do we know that AB and CD are congruent? Remember when I was talking about transitive, it was two things that equal the same thing, therefore they can equal each other? Has to be the case for transitive. Okay, for this, it goes from, these two both equal BC, so now they equal each other. That's transitive. You always have to ask yourself that question and say those words in your head. If two things equal the same thing, they equal each other. They both equal BC, so they equal each other. Okay? And then here, notice, okay, we're not going from congruent to equal, but something is happening. We're switching sides. So we've got to look back here. Okay, which one switches sides? It's going to be here. It's going to be symmetric property. That's all that happens is they switch. Symmetric property. Okay? Alright, moving right along. Last one. We're going to do both sides. We're going to do this together. So 2AB equals AC. And then what we're trying to prove is down here. Okay, well, this is saying that two of these is congruent to the whole thing. Alright, so we need to somehow figure out that AB is also congruent to BC by using these steps. Okay, so this first part's given. This is what we're trying to prove, but we'd never write the word prove. And then we look at this picture and we're like, okay, well, I'm trying to figure out, I need to somehow get BC in here. And if we look at this, there is a way to make BC appear, because we have this part plus part equals whole reason. So we could always write that out. So our segment addition postulate tells us that AB plus BC equals AC. Okay, so that makes sense. That's a way for us to get BC onto this statements column, okay, because we need it for the final product. Alright, and then if we're looking at this, we're like, okay, I've got to get, AB and BC on the same equation, but I don't really want AC to have anything to do with it, because AC is in the given, but AC is not what we're trying to prove. But remember what we talked about last time. Two things that equal the same thing will equal each other. So both of these equal AC, therefore they're going to equal each other. Okay. So that is going to be transitive. Okay, now we're making it work. Now it's making sense. Now we got to figure out, okay, can we get BC all by itself? Because that's what we want for the final step. It would be like, what do we have to do to get AB on the other side? Well, you could subtract AB on both sides, and it would look something like this. 2AB minus 1AB will equal BC. So 2 of these minus 1. Well, what do we do on both sides? We subtraction property of equality. because from here to here, how we get there, we subtracted AB on both sides. And then from here to here, now we're subtracting, but it's on the same side of the equation. So all that it is you are just simplifying. Okay, it's combining like terms, it's simplifying because it's all happening on the same side. So simplify / combine like terms. All right.